Okay, good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. Okay, the date for today is November 25, 2024, and the time is 1:58 a.m. Okay, my topic for this morning will be a long video format topic on my subject matter, analytic geometry, and we are now, or I am now on lesson number 20. Okay, let's proceed. For the past days, I've been doing some short videos on so many topics like electronics, travel time, uh, uh, cooking foods, and other things. So for this morning, we'll go back to long video format discussion because the contents of my channel is actually long video format topics. Uh, Actually, I uploaded already 12 subjects under my long video format topics, and these are differential calculus, integral calculus, differential equation, advanced math, AC circuit, AC machine, DC circuit, algebra, analytic geometry, and the last one is actually DC circuit. I've got 10 topics already uploaded. It's a complete syllabus. So for those of you who are planning to take up engineering, whether it is here in the United States or America or any part of the world, you can use my channel to learn something about differential calculus and other things. It's a long video format discussion. You will learn something from it. And for the short videos, my short videos comprises of multi-topics. It could be something like math problems, which are in the range of 15 to 60 seconds. We call it short videos. I've got some electronic topics also. I could do troubleshooting or any topic that's very relevant in the so-called troubleshooting of electronics. I know how to troubleshoot electronics, from the schematics to the so-called circuit diagram or on the actual circuit. I could do soldering. Actually, I could do what you call this assembly of electronic circuits like EM receiver, FM receiver, amplifiers, uh, regulated power supplies, and many other things. Okay, let's proceed with the topic for this morning. It's a long video format discussion on my long video format topic, analytic geometry. The subject matter for this morning will be a continuation of my long video format topic, analytic geometry, and this is now lesson number 20. We are almost done with the analytic geometry because after this maybe we will be taking the study of circle, in the last part maybe hyperbola. Those are only the most important things under the topic analytic geometry. Okay, let's proceed. Analytic geometry lesson number 20, and the title of the topic will be Ellipse example problem. For the last two sessions under analytic geometry, I have discussed the concepts of ellipse with center at 0, 0, or ellipse with center at HK. So for this morning, I will be discussing an example problem illustrating those concepts. Okay, I will try to give you the problem. Find the center of the ellipse. With equation, we are given the equation of the ellipse. X squared plus 4x plus 2y squared minus 12y equal to 14. That's the equation of the ellipse. The problem is asking where will be the location of the center. Center. It is this. You must have to bring out the solution of the location of the center. And actually the answer is actually as negative 2, 3. That's the answer, but we must have to go back to the solution to bring out this one. And the other requirement of the problem, find also A and B, then draw the ellipse. So actually, we are required 4 things here. We must have to determine the abscissa and ordinate of the center, the value of this major axis A and major axis B. Semi-major, okay, and semi-minor, because 2A is actually the major axis, or A and B, then the last part will be, we must have to draw the graph of the ellipse. Okay, let's try to bring out the solution. We will rewrite the given equation, x squared plus 4x plus 2y squared minus 4y equal to 14. Okay, that's a quadratic equation involving x and y. Okay, then we'll try to rearrange or manipulate a little bit the given equation, because the coefficient of this y squared term here, the coefficient of y squared is 2, so we also have to do something about it, because in the so-called completing squares, it's a must that the coefficient of y squared will be 1 for the meantime. So we could rewrite the given equation to be x squared plus 4x plus 2. We factor out 2, we bring it out, times the quantity y squared minus 6y plus quantity, and this should be equal to 14. If we try to expand this one, it will be still the same as this one, because 2 times y squared is 2y squared, and 2 times negative 6y is negative 12y. But we could do this one as another form. Then we'll try to complete the squares. Completing the squares, meaning we'll try to make the so-called x and y term a complete binomial, what you call this, a binomial thing, so that when we try to expand, it will become a trinomial, it will become a 3-term. But we needed another, a constant in which to be added for it to become a perfect trinomial of the so-called trinomial form. So completing the squares, okay, this is now a part of algebra. For x, the added number here for it to become a perfect trinomial will be, we will take the coefficient of x here. We'll take 1/2. Then we'll try to square it. Okay, that's the procedure. That's the procedure from algebra for completing squares. Whatever the coefficient of the x term, we will take 1/2 of that, then we will try to square that one, and what will come out, okay, will be 4. Because 1/2 of the coefficient of x is actually 4. So this is 1/2, close quantity, close bracket, quantity square. If we try to simplify this one, we'll simplify first inside. 4/2 is actually 2, 2 square is actually 4. So the square of this one will be 4. Meaning to say, for the x term, for it to become a perfect binomial thing, we will add up 4. Okay? For the y term, we will take the coefficient of y squared. No, the coefficient of b. We will take 1/2 of the coefficient of b, of y rather. Okay, we are now in the y term. So this will become 1/2 of negative 6, close bracket, quantity square. Forget the 2 pairs. Minus 6/2 is actually negative 3, and negative 3 square will be 9. So the square of this one will become 9. Meaning to say, for the y term to become a perfect trinomial, we will add up 9. Okay? So after presenting this one here, we'll try to add 4 and 9 to both the left and right. Okay? So this will become x squared plus 4x plus 4. Actually, we could enclose this one into one quantity, because this is now a perfect trinomial. Okay? And for the second part, we will just copy this one. This is 2 times y squared minus 6y this 9 here should be inside. Okay, so this is plus 9 plus quantity, and this should be equal to. The original right hand side is 14. We add 4 here, so we add 4 here. For the y term, the added term should not only be 9 because there is a 2 here. So the total constant that is added to the y term is actually 2 times 9, so that will be 18. Okay? According to our computation, for it to become a perfect trinomial for the y term, we should add up 9, so we plus 9 here. But the problem is there is a 2 outside. Okay? So actually we added plus 18 to the y term. So this is plus 18 also on the right hand side to balance things, right? And actually this should be all with one quantity. And the first part here, this is a perfect trinomial, and this is actually an expansion of a binomial term, which is the binomial term is actually x plus 2 quantity square. Because if we try to square this one, it will be x squared. Middle term will be 2 times x times 2 will be 4x. And the last part will be the square root 2, which is 4. So actually this perfect trinomial is the equivalent of this binomial square here. Right? Plus 2. This one here, this is now a perfect trinomial, right? And we could, simplify this one as the expansion of a binomial term. And that binomial term is actually y minus 3 quantity square. Because if we try to square this one, the square of y will be y square. The middle term will be negative 3 times y times 2. That will be negative 6y. And the last part will be the square of negative 3, which is plus 9. So this perfect trinomial y square minus 6y plus 9 is actually the equivalent of the binomial term y minus 3 quantity square equal to. Adding the right hand side, it will become 18 plus 18. That 14 plus 4 is 18. So 18 plus 18 will be 36. Right? And if we are on the study of ellipse, as I have been shown on the previous discussion on the concept, the right hand side should always be 1. Right? Plus, the sign of the terms on the left hand side, for it to become an ellipse, it should be a plus. This is a plus. Okay? For an ellipse, this should be a plus, and the right hand side should be 1. That is ellipse. Because just in case this is negative, it will not become an ellipse. That's another formula. Okay? And to simplify the resulting equation, for the right hand side to become 1, actually we will multiply all the terms by 1 over 36. Right? So the right hand side, 36 times 1 over 36, this will become 1. And x plus 2 quantity square divided by 36, this is now over 36. The second term will just be simply 2 times the quantity y minus 3 quantity square. We will multiply that by 1 over 36, so 36 will go underneath. Right? And if we try to simplify now, this will become x plus 2 quantity square. 36 is a perfect square. It will be the square of 6. Plus, actually, these two here cancel with this, and this will become 18. The bottom portion here on the y term will be 18. And 18 can be written as 3 the square root of 2, right? If we try to take the square root of this. Right? So for it to become a perfect square, we will place the square root of 18 to be 3 the square root of 2. So this is 3 square root of 2 quantity square. And this should be equal to 1. And this equation here is actually the equation of an ellipse with center at HK. Okay? The longer length is actually underneath the x term, in which the major axis is 6. And the semi-minor axis is actually 3 the square root of 2. So this equation here is similar to this. Okay? And what we are looking for is this value here, and this value. So from this, since this is now a minus, a plus, actually h is actually negative 2, right? And for the y term, this is just a plain minus 3. So meaning to say the k is actually a positive value, and the value of k will be a positive 3. See, so the location of the center of the ellipse is at the location negative 2 and 3. This is the center of the location of the center. Ellipse, sorry for that one. This is the center. This is negative 2 and this is 3. This is the, sorry for that one, the origin. The origin is actually at 0, 0. This is the center of the ellipse. This is. Okay. Negative 2 to the left. Upward is actually positive 3. This is the center. Okay. Okay. The other thing. The value of A is actually 6 units. The one underneath the X term. And the value of the B term is actually the one underneath the Y term. Because 3 the square root of 2 is actually less than 6. So this should be the major axis and this is the minor axis. And the value of B is actually 3 square root of 2. And if we try to take the approximate value, that will be 4.24 units. So the center location will be at negative 2 and 3. Value of the semi-major axis is 6 units. And the value of the semi-minor axis is actually 3 square root of 2, or that will be 4.24 units. And if we try to bring out the graph, like what I said, this should be the y-axis, this is the x-axis, the location of the center of the ellipse is actually at negative 2. Abscissa is negative 2, this is negative 1, negative 2, and the ordinate is actually 3 units up. So from the x-axis, it should be moved 3 units upward, 1, 2, 3. So this is 3. So then the intersection of negative 2 and 3 will be the center. So this is the center of the ellipse. That's the center. Okay. The major axis is actually along the x-axis. This 6 is actually under this x term here. So the major axis should coincide with the x-axis. And the length of the major axis is actually 6 units. 6 units, this is 6 units. Why 6 units? Because to the left of y, there is a 2. So for it to become A equal to 6, we add 4 more, right? 1, 2, 3, 4. So this is 2 plus 4, that will be 6 units. 6 units. Right? This one, it's also 6 units. It's not only drawn to scale. This is also 6 units. Okay? So the major axis is actually along the x-axis. And the minor axis, the shorter one, 4.24. So with respect to the center, this is 4.24 units. Okay, the lower portion is also 4.24 units. Okay, that's the graph. Okay, this is the center locations, negative 2 and 3. This is the length of the semi-major axis, 6 units, 6 units. The length of the semi-minor axis is 4.24. This is 4.24, 4.24. So we try to connect these 4 points here. That should be the ellipse. And the equation of that one is actually x squared plus 4x plus 2y squared minus 2y equal to 14. This was the original equation given. Okay, that's it, guys. That's the way how to solve problem under the so-called study of ellipse. The solution is just by using the so-called completing squares. And at least we know how to graph a semi-major axis and a semi-minor axis. Like what I said, for the equation to be an ellipse, the sign on the left-hand side should be plus. Okay, and the right-hand side will be 1. Okay, so for those of you who would like to watch my long video format topics under my channel is at youtube.com/at Prof. David J. De Los Reyes. Okay, I got 12 long video format topics already. You will learn something from it. So for this morning, this will be an example problem of an ellipse. Okay, good morning from Los Angeles, Professor David J. De Los Reyes.